Level 3 teaching of multiplication, calculation. So how you could use level 3 teaching to support the student become fluent in calculating multiplication. The Common Core standard grade 3 talking about how to support the student develop fluency. Use multiplication and division within 100 to solve word problems in a situation involving equal groups, arrays, and then measurement quantities. So actually that in multiplication within 100 means basically the single digit multiplication. 1 times 1 to 9 times 9. And then Common Core expects students to apply this property of operation and strategy to multiply by divide. So we want students to coming up the multiplication facts by using what they already have learned. And then the fluently multiply divide within 100 using strategies such as relationship between multiplication and division. So we want students to become fluent, not just in simply memorizing it. We want the student to use strategy to identify the multiplication facts. And then repeat this process. And then eventually we want the student to automatize this process. And then fully comfortable recite this the multiplication facts by themselves. Again, this is different from simply memorizing multiplication fact versus using strategy to repeat this process and then automatize this process. So, from that viewpoint, it is not a good idea to giving a multiplication table to the student. We want the student to develop multiplication table. So the level 1, level 2, probably teacher gave a completed multiplication table to the student, and level 1 is just let student memorize it. Level 2 may explain what kind of interesting pattern or what is the reason behind the multiplication table. However, level 3 teaching, we want, the work with students to develop this multiplication table. So when you develop this multiplication table, where are you going to start this? Do you think 1 times 1 is a good place to start? Of course, 1 times 1 is 1. But think about it. If you have a 1 bottle of water, do you think students can easy to see 1 groups of 1? They typically say, oh, this is just 1 bottle. It's harder to see 1 groups of 1. So, getting answer 1 times 1 is easy. However, it's not easy to, develop a concept of 1 groups of 1. So, it is more abstract. So therefore, it might be a good idea to you to come back 1 times 1 when they fully develop the notion of multiplication, equal group situations. So where are we going to start? So remember, students already have worked with the group of objects. And then in the kindergarten, 1st grade, they do a lot of counting activities. Counting by 2s, counting by 5s. Some teachers encourage students to use count by 3s. So you should begin with this. And then start filling out this using count by 2s or count by 5s. So this part is number in each group. This is a number of groups. That means you could start from one column, for example, either 2 or 5. Let's begin with 2. One groups of 2 may not be a good idea, because if this is 2, just 2. How about 2 groups of 2? Well, 2 groups of 2 is a little bit tricky, because what is a 2 plus 2? 2 plus 2 is 4. What is 2 times 2? 2 times 2 is also 4. So it might not be a good idea to start with 2 plus 2. This is a very special situation. The addition and multiplication have the same answer. So it might be a good idea if you want to start with 2's, maybe 3 groups of 2, just like the bicycle situation I showed you. So 3 groups of 2 is 6. How about this? The bicycle increase. So 2 more, so that means 8. So that each time bicycle increase, 2 increase. So using some particular situation, like increasing bicycle situation, or increasing the 2 apple on a plate, so then so that the student can see, okay, each time 2 increase. And then how about, and then you can coming back. How about if we only have 1 bicycle? Well, just 2 wheels. And then 2 bicycles, 4. And you could walk this. I did very quickly. However, you can spend time in a whole class and then discuss this one. And then students become comfortable asking students to find out another situation which is increased by 2. So like each case has a 2 hand or a pair of shoes. Those are things that you do to repeat this situation, and then encourage students to see the group of 2's, if that the number of group increase, always increase by 2. And maybe 5. 5 is like a finger in each hand, that is the 5. So in this case, maybe you could begin with 2. Like 2 hand, we have 10 fingers. And if you have, if you go to the kindergarten classroom in elementary school, there are a lot of like a hand stamp on the wall. Maybe you could count this one. And then in this case, students say, oh, each time now increase by 5. And then what happens if this is one group? This is 5. So this is another day to complete these 5s, 2 and 5s. So this is relatively easy for students to find this, the relationship. Okay. And then some students become familiar with like 3, the group of 3's. And then again, it's important for students to find a group of 3 things. And then using this like a tricycle can be a way. And then, how about probably it's maybe a good idea to start with 2. Okay, 2 tricycle, it is 6. Okay, 3 tricycle, 9. And some students still comfortable skip count by 3. Okay, 6, 9, 12, 15, and or I got 18, 21, 24, 27. So, and then coming back, this is 3. And then look for like a group of 4. What is a group of 4? Well, like, the legs of chairs, always, mostly 4. So those are things that you look at, examine this. And then you could fill out this like 4, 8, and then 12. And student might realize, okay, well, look at this 4. 4 is double of 2. And then look at this, each times It's become double. I hope students can recognize this. And then therefore, one way to find out 4 times 4 is adding 4 to 12. However, another way is double of 8, which is 16. And you have two ways. So this is increased by 4, 16 plus 4 equals 20, but at the same time, double of 10 is 20. So we have two different ways to find out. And then after 1, 2, 3, 4, 5, you finish. Maybe you can come back group of 1. What if we have a 1 plate and then only 1 apple on the plate? And how many? So in this case, number of plates and the number of apple are the same. So you could. It's important always to show a concrete situation rather than simply number patterns. Okay, so the 1 through 5. It's relatively easy because they already knew this skip count by 2s, 4s, 5s, 3s, and the 1s. So, and then after this, so now this is more challenging. The number become bigger. So how you could help students to coming up a variety of ways to filling this multiplication table. Of course, one way is 6 group of 6. Again, you want to show student a group of 6 and then talking about, if it's one group of 6, 6. So the two groups increase by 6. So that each time must be increased by 6. So 12. That is another way. And then the second way we've been talking about is doubling. So the 6 is double of 3. So do you think this is double? Yes, this is double. Maybe this is 18. So in this case, and also it's a double of 9 and also 12 plus 6. So, the double of 9 and then 12 plus 6 bring 18. So two different ways. And maybe students realize this one. Okay, so this, if you look at this in vertical ways, 4, 8, 12, 16, 20 increased by 4, so therefore must be 24. Is that true? Yes. 18 plus 6 is 24. And also double of 12. So we have 3 different ways to find. And then use these 3 different ways to fill out this to help a student. So it's always good ideas to encourage students to coming up a multiple way to find out, so that student forget the multiplication facts, but they can reproduce. Okay, let's see. How about 7? 7 is of course, you can use all these, the previous approach. However, you may not be able to use double because 7, there is no doubles. Do you think any other way to find out instead of using double? Of course, you can add 7 and then 14. Or you could use vertical way, like 3, 6, 9, 12, increase by 3 must be 21, and then increase by 4, 28. However, how about this? Instead of using double. A student might realize, okay, let's see, 7, we do not have a double or something. However, 7 is, you can find 3 plus 4. 3 plus 4 equals 7. Okay, let's see. 3 times 5 equals 15. 4 times 5 is 20. How about if we add this, like 35? Is that 35 true? 28 plus 7 is 35. Okay, so this is 30, and then increase by 5, 35. So this works. So because 7 is 3 plus 4, so therefore we plus this one. Well, if we have a good number sense, 7 is not only 3 plus 4. Maybe 2 plus 5. 7 is 2 plus 5. Do you think the 2 plus 5 works? So the 12 plus 30 is 42. Is the 42 works? 35 plus 7 is 42. Okay, this is 36. 36 plus 6 is 42. It works. How about 1 plus 6? 1 plus 6 is 7 plus, this is, so 49. This works too. So we could use this number sense we've been developed in the first grade. 7 equal 3 plus 4. 7 equal 2 plus 5. 7 equal 1 plus 6. All of them, these decompose, works for multiplication. Now you realize we have particular name of this property. This is called distributive property. So that means 7 times, for example, 8 is 3 plus 4 times 8. So which is 3 times 8 plus 4 times 8. Let's look at this. So the 3 plus 4, 8. So this is 3 times 8 is 24. 4 plus 8 is 32, which is 56. Student realize commutative property, distributive property. And then also multiplication increased by each number in each group. So those properties students can realize by themselves. Therefore, that the process of filling out is very important. Level 1, level 2 teacher tells them. Even level 1 doesn't tell. Level 2 explain. However, actually, if the student walk out by themselves, teacher facilitate discussion. That is so powerful. So these are what Common Core State Standard expect. And for the level 3 teaching. So then student fill out this multiplication table. Usually it takes like a month, the nearly month to spend this one, and then they become fluent. You do a lot of game to practice. And then once it's become fluent, and we want the student to go much further. Let's see. And then teaching through problem solving, asking student to solve the problem, which not necessarily to be an everyday wordy story problem. So how you calculate multiplication is also can be a problem. And then if you ask student to come up this one, the various solution method coming up. Although like answer is same, but the approach may be different. And then teacher's job is not just stop at the show and tell, and then beyond show and tell to discuss how you come up with this solution. So for example, 12 times 4, assuming that the student already comfortable single-digit multiplication facts. How are you going to do this? Well, student might split. Well, 12 they have not done because they run 9 times 9. And also 10 times something is relatively easy because using the 10 as a unit to do this. So for example, 20 times 4 is 2 tens and then 4. So 2 times 4 tens. So you can simply implement this, simply use this idea from single digit multiplication to calculate tens numbers. Okay, so let's see. One approach is, but 12 is too big because we do not know yet. So therefore, I'm going to make this one into single digit. How about this? I really love to make it half. So now it's become 6 times 4. So this time 6 times 4. 24. 24. So therefore 24 plus 24. 48. That's a way to do this. Another way, maybe, I could split this one to 10 and 2. Because I know 10 times 4 is 40. Also, I know 2 times 4, 8. So 40 plus 8 is 48. So then some students say, well, I can spread this one into like this. 8 and 4. As far as you cut this 12 into 2 pieces, you could use single digit multiplications. And then teacher facilitate discussion to help students understand each other, and then which might be a way to do this. And then you could extend this one to 12 times 7. So how you cut this one? The similar situation. And students who just simply use repeated addition for the prior lessons, encourage them to try not using repeated addition. And then instead, you could cut this one you cut this one in 6 and 6. Or even like 8 and 4. To use this single digit multiplication. And there is a student work actually. And student coming up variety of solutions. And teacher facilitate discussion to help student to understand them. And which might be easy. Of course, you can chop into small pieces, but it takes long time for calculation. The smaller cut, like this, is much better than chopping into small pieces. And what happens if this has become 23 times 3? How can we make it, like a smaller chops? So the 23 may be 1, 2, 3, 4, 5, 6. I like 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5. So that means we could chop into 23 into 6, 6, 6, 5. You can calculate 6 times 3 is 18. And this is also 18, 18. And then this is 6 times 5, 30. And you could add them all. Sorry. This is 5 times 3. So you could do this. However, some students may say, oh, if you chop into small pieces, it's going to be a lot of work. I want to cut this one into 20 and 3. So the 20 times 3 is 2 times 3 tenths, which is 60. Easy. And then this is 3 times 3, 9. So 60 plus 9 is 69, which is much easy. So students coming a variety of solutions, but the teacher helps students to compare and then think about it, which might be the easy way. So the 23, rather than chop into small pieces, chop into tens and ones as the ideal way to do this. So that's the kind of things like first you want to do this 12 times 4, 12 times 7, just we did. And then you add, apply these procedures to try to using chop into to this, to away from repeated addition. And then maybe apply to the story problem. And next one is 20 times 3, like tens numbers and hundreds numbers. And then apply to this one. And then come to 23 times 3 that we just did it. And then chop into tens and ones is much more easy. And let's try to solve this problem. So, and then go to 3-digit multiplication. So how about 312 times 2 and that kind of discussion. And then go to fluent. So this one is like each is one period of lesson, 1 day lesson. Next day, another day. It takes like 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 days, slow pace, but it's go deeper. And then each time, let them struggle to find out. These are kind of teaching through problem solving lesson. And then the green part is more like a developing fluency. Try these ideas to, by themselves. That's the kind of ideas. And then what happened? Like a 12 times 12, 23 multiplied by 12. So from the past experience, it might be a good idea to chop into 20 and then 3. This is a way to divide 23 into do this. And how about 12? We could chop this one too. And this is 10 and then 2. So how about this part? This part, how you calculate? This is 20 times 10. How about this part? This is 3 times 10. This part is 20 times 2. This part is 3 times 2. And then you combine this. So if you chop into tens and ones, 23 multiplied by 12, we need to divide into 4 pieces. And then each of them are basically simple application of single-digit multiplication. So if you chop into 4 pieces, all you need is single-digit multiplication to calculate 2-digit by 2-digit. That's the idea of this. 2 times 3 is 6. Where is this? Is this. How about 2 times 20? This is 40. This is here. How about 10 times 3 is 30. It's here. How about 10 times 20? Here. This is 200. So if you add them all, this is 276. That is we call partial products. So you could have, now you have a reason why you have to multiply by 4 times. If you write this one using more algebraically, so this is actually you divide 23 into divide 20 plus 3 times 10 plus 2. So if you divide this way, it becomes 20 times 10 plus 20 times 2 plus 3 plus 10 plus 3 times 2. So which is exactly the same idea with this part is this part is this part is this, and this part is this. So, and we want students to come up by themselves. And believe or not, students can come up. They may not know this notation. However, you could introduce this vertical form to the student after student discover this part, to help student to to introduce a formal way of calculation. And then for this part, this notation, you don't have to teach this one at this moment. But this is, for us, we need to understand this. Okay, so let's see. We are talking about 23 multiplied by 12. However, what is this? What if this is 5x plus y, 3x plus y? So in this case, we could say this is 5x. This is y. This is 3x. This is y. So 5x plus y multiplied by 3x plus y is 5x times 3x, which is here, plus 5x times y, which is here, plus y times 3x is y times 3x, it is here, plus y times y, which is here. So this is 15x squared plus 5xy plus 3xy plus y squared equal 15x squared plus 8xy plus y squared. So you learn this one. But this is the idea exactly same as 23 multiplied by 13, like this. So if you really understand the mechanism of this calculation, this algebraic manipulation is not so challenging. So you understand. So when you teach 23 multiplied by 13, we help students to develop this foundation for algebra. That's something we need to think about it. And how about 138 times 45? You can divide 138 and then 40 and then 5. So now this time 1, 2, 3, 4, 5, 6 calculation you need it. So we want students to understand even the number of digit in multiplication increase, we need only single digit multiplication facts. to calculate this. So we teach this algorithm for students. It may not be practical use. However, we really want students to understand what is the mechanism of this multiplication algorithm. Because if you use place value notation and single digit multiplication, basically any whole number calculation, you can do it. That's a mechanism of algorithm, which is very important notion. Many programming, the softwares, are using algorithm like this, the combination of single process to be able to accomplish all these variety of the problems, tasks. So the Common Core state standard is, go to like grade 4 to focusing on multiply whole number of 4 digit by 1 digit, and then the large number, and then go to 5th grade, and they're gonna extend this one to decimal numbers, and then also multiply and divide by fractions, and then 6th grade fraction multiply by fraction. That's the progression that they go. So it's important not just teach how to calculate, but we want the student to coming up their way of thinking so that the student can understand the reason behind of this.